Welcome back, friends. And today in this session we are going to see some more classifications of the signals. So in that, let's see one more classification, which is periodic and aperiodic signals. Periodic and aperiodic signals. Let me change the color. I think it's not visible. Periodic and aperiodic signals. Aperiodic means non-periodic. Okay. Now try to understand. When can we say a signal is periodic? First of all, we have to understand, to say a signal is periodic, it has to satisfy a prior condition. What is that condition is, the signal must exist from minus infinity to plus infinity. That means t value has to change from minus infinity to plus infinity. The signal should not be 0 for minus infinity to plus infinity. That's what the meaning of it. So the first condition is prior condition. Prior condition. What is that? Signal must exist from minus infinity to plus infinity. Signal must exist from t is equal to minus infinity to t is equal to plus infinity. This is the prior condition. Okay. Once this condition is satisfied, then we have to say the signal is a periodic. Only if, suppose if it is a continuous time signal, it has to satisfy this property, that is x of t plus or minus capital T is equal to x of t. That means if you shift the signal x of t rightwards or leftwards by t seconds, capital T seconds, then still you have to get the x of t signal. Means you have to get the same signal. So while you are shifting rightwards or leftwards, you have to get the same signal. Then that signal is called as periodic, and capital T is called as fundamental period. Capital T is called as fundamental period. Fundamental period. Do you know what is the definition of fundamental period? Fundamental period is nothing but the minimum duration of time after which the signal is getting repeated. After which the signal is getting repeated. So I am writing that it is the minimum duration after which signal is repeated. Signal is repeated. This is what called as fundamental period. So try to understand this. Suppose if I take a signal like this, x of t signal, zero, let's say 1, 2, 3, minus 1, minus 2, and so on. It has to go infinity, it has to go in this direction infinity. If I say what is the fundamental period of this signal t, which is nothing but 1 second. 1 second. Why? This is the minimum duration after which the signal is keep on repeating. The signal is keep on repeating. Period can be anything. That means suppose if I take 0 to 2 seconds. So if I take this block, if I make them keep on repeating, still I can get the signal. That means if you know the fundamental period, any integer multiple of fundamental period is also called as period. But remember, what is the fundamental period means? It has to be the minimum duration. So if somebody is asking time period, so default it's always going to be a fundamental time period. Okay, so this is what the minimum duration. Okay. Now, what is the unit for this? Just now we have mentioned that unit is, I can say, seconds. Unit is seconds. And t can be integer, non-integer, or any real number is okay for us. So there is no restriction on capital T. So period of a continuous time signal can be anything. Suppose if I take another signal, sin t. How it look like sin t? This is how it look like: 0, 2 pi, pi, 3 pi, and so on it will go, minus pi, minus 2 pi. So if you see, after how much time it is keep on repeating. So let's say this is the period. This is the period. Because 0 to 2 pi, if you take this wave, after that this keep on repeating. So I can say time period in this case is 2 pi seconds. If you observe carefully, t is 1 second, maybe it is an integer, and t is equal to 2 pi, it is not an integer. So I can say t value can be anything. So maybe integer, maybe fraction, maybe irrational number. Any real number is okay for us. Okay. So this is about the continuous time case. First take the continuous time case, then we will see the discrete time case. Okay. Take it. How can we say a discrete time signal is periodic or not? Let's see. Suppose if we take x of n plus or minus n, capital N, is equal to x of n. So if we shift the samples by n samples, then we can say it is a same signal. If it is a same signal, then we can say it is a periodic signal. Then n is again called as fundamental period. Fundamental period. Now you tell me, is there any restriction on n? That means, can be a integer, or can it be a fraction, or can it be any real number? Answer is no. It cannot be anything. So it has to be integer only. It has to be integer only. Why it has to be integer? Because you know it is a discrete time signal. In the discrete time signal, we already seen that non-integer shifting is not possible in the discrete time case. So I have to say, because it is a discrete time signal, if you want to shift the signal by n samples, n must be integer. N must be integer. So remember, in a discrete time case, the fundamental period always represented in integers. Okay, that is a compulsory condition. N must be integer. N must be integer. Next, one more thing I want to say. What is the unit of this n? It is not seconds. So the unit is samples per cycle. Samples per cycle. So let's see, what do you mean by that? Suppose if I take an example, you can understand. Okay. So let's call it as x of n, and it is a periodic signal because there is a repetition. There is a repetition. Now, if somebody is asking what is the period of the signal n, then you have to see, don't say it like a 3 minus 0 like that. So it is not the way we have to calculate the period of signal. The length in the discrete time signal means it is always number of samples. Remember, length in the discrete time signal means it is always length of length means it's a number of samples. Now if you see how many number of samples are keep on repeating, that means let's say 2 1 0 2 1 0 2 1 0 like that. So 3 samples are keep on repeating. What are those 3 samples? I can say 2 1 0 2 1 0. So I can say yes, here we are having in one cycle 3 samples. In a one cycle 3 samples. 0 also we have to consider. So 2 1 0. So I can say these are the 3 samples per cycle. Samples per cycle. Understood? So n must be integer. And see, x of n can be represented like this: 2 1 0. And beside that, if I write n is equal to 3, what is that supposed to mean? If any discrete time signal is represented in this manner and they have said period is equal to 3, that means it is a periodic signal and these 3 samples are keep on repeating. Sir, if they haven't mentioned the arrow position where it has to be, remember in the discrete time signals, if arrow is not mentioned, then default position is always first sample. First sample is always taken as a 0 position. So if it is mentioned or if it is not mentioned, you have to understand that this is the 0 position. N is equal to 0 position. Understood? Okay, take it. Let's say some standard signals, how to find out the period for those signals. Okay, so if any waveform is given, you can find out what is the period. Suppose, let's say, in a continuous time case, suppose if it is given, let's say, sine omega naught t plus theta x of t is equal to, or x of t is equal to cos omega naught t plus theta, or x of t is equal to e power j omega naught t plus theta. If these kind of signals are given, then directly you can say what is the fundamental period is for all of them 2 pi by omega naught. 2 pi by omega naught. These two signals are called as continuous time sinusoids, and this signal is called as continuous time phasor. So for a continuous time sinusoids and a continuous time phasors, always period is equal to 2 pi by omega naught. Just you have to see what is the omega naught value. Okay. But in the discrete time case, suppose x of t is equal to sine omega naught n plus theta, x of t is equal to sine cos omega naught t plus theta, omega naught n, x of t is equal to e power j omega naught n plus theta. So it's the same kind of sinusoids and phasors, but in the discrete time case are given. Then how to calculate the period for them? N is given as same formula 2 pi by omega naught into m. M must be there. See, try to understand this. 2 pi by omega naught, I don't know, maybe integer, maybe fraction. But m value has to be in such a way that we have to select m value which is a minimum integer. Remember, m value has to be minimum integer such that it has to make this total fraction or total term into an integer. I hope you understood. M value must be the smallest integer which makes this total value into an integer. That's what we have to select. Okay. So select m in such a way. Select m which is minimum integer, which is minimum integer, which makes n as integer, n as integer. So try to understand this. These are discrete time sinusoids. And this is a discrete time phasor. Discrete time phasor. Suppose if I take an example like this. Sine 3 pi n. So for this, if I try to find out what is the n, that means period of the signal. Suppose if I give 2 pi by 3 pi. So if I take this one, pi get cancelled 2 by 3, which is non-integer, which is a not integer. So I can say we want to make this into integer. So we have to select m value. So m value must be a minimum integer, which makes this total thing into integer. So what should be the minimum integer I can select? I can select m is equal to 3. If I take m is equal to 3, they get cancel each other. Then finally 2 is nothing but the period of the signal. I hope you understood how to select the m value. Okay, take it. Examples. Example 1. Sine 7 pi t. For this, can you find what is the period of the signal t? Which is nothing but 2 pi by 7 pi, which is pi get cancelled, 2 by 7 seconds. 2 by 7 seconds. Next. Sine 70. Sine 70. For this, what is the period? So directly the formula 2 pi by omega naught, which is 7. So directly yes, this is a irrational number, still it is going to be the period of the signal. Third one, sine root 2 t. T is equal to 2 pi by root 2, which is root 2 pi. Yes, this is also allowed. So this is also can be period. Okay. Now let's coming to the discrete time case. In the discrete time case, let's say sine 7 pi n. Same thing, but I have written sine 7 pi n. What is the period of the signal n? N is equal to 2 pi by 7 pi into m. So pi get cancelled. M value has to be chosen as a minimum integer such that this value makes it into integer. So 7 I can choose it as. So then it is going to be 2 samples per second is the period. Next. Fifth one. If I write 7n, sine 7n. For this, what is the period? N is equal to 2 pi by 7 into m. 2 pi by 7 into m. So m value we have to choose such that this whole thing makes into integer. Here listen carefully. So many people will do so many mistakes here. First of all, they will take m as 7. M is equal to 7 if. Then what will happen? This will become n is equal to 2 pi. But it is not correct answer. Why? N has to be integer, so that it is not a correct answer. Some people will take this. If m is equal to 7 by pi, then n is equal to 2. It's okay. N became integer. But is m integer? M value. I told you m value has to be integer, but it is not an integer value we have chosen. We have chosen a non-integer value. That's another wrong thing. So we cannot select m value is equal to 7 by pi. But some more intelligent people can think that if m is equal to 49. Sir, why 49? Actually, what they will do is n is equal to 2 pi, 2 by 7. Pi value can be taken as 22 by 7 into m. So finally, this is 44 by 49 into m. They will take it as 44 by 49 into m. They said m is equal to 49. They get cancelled. Finally, 44 is the answer. but you cannot take pi is equal to 22 by 7. Why? Pi is definitely a irrational number. What do you mean by irrational number? If you keep on writing that value, the decimal value keep on goes to up to infinity. So you can never find that exact value. So it is an irrational number, non-recursive decimal. So it is going to be irrational number. But what you have written 22 by 7, which is nothing but p by q, integer by integer form. That means rational number. So you cannot represent pi as 22 by 7. So actually whatever we have studied, pi is equal to 22 by 7 is an approximate value. So it's not exact value. So you cannot say pi is equal to 22 by 7. That is also you cannot take it. Remember. So because it is an irrational number. Finally, there is no m value which makes this into integer. So I can simply call this is a aperiodic signal. First of all, it is not a periodic signal. That's why we are not getting integer value here. So it is aperiodic signal. Aperiodic signal. Aperiodic. Remember, it's a non-periodic signal. So I can say there are sinusoids in the discrete time case which may be periodic, which may not be periodic. Okay. So let's see some more examples. Sixth one. Sine pi square n. So n is equal to 2 pi by pi square into m. Pi get cancelled, m value cannot be chosen as pi. So again it is a periodic signal. Again it is a periodic. Next. Sine 3 by 4 pi n. For this, what is the period of the signal? Let's see, n is equal to 2 pi by 3 pi by 4 into m, which is 8 by 3 into m. M value has to be chosen as 3. Finally, this is going to be 8 samples per second. Yes, it is a periodic signal with a period is equal to 8 samples per cycle. Okay. So this is about it. Now, my conclusion point or my observation, what I have to make. See here, continuous time sinusoids are continuous time phasors. That means sin omega naught t, cos omega naught t, or e power j omega naught t. Without much thinking, I can say they are periodic. They are nothing but periodic. So I can say continuous time sinusoids are always periodic, or we can say continuous time sinusoids are phasors and phasors are unconditionally periodic. Whereas coming to this one, discrete time cases, they may be periodic, they may not be periodic, but I can say conditionally periodic. What do you mean by conditionally periodic means? That means they must satisfy some condition, then only we can say they are periodic. So if I ask, what is that condition they have to be satisfied so that they can be periodic? What is the condition on discrete time case so that they can be periodic? Some people will say multiple of pi. What do you mean by multiple of pi? So here, pi square, pi into pi, yes, that is also multiple of pi. So we cannot say like that. Some people will say integer multiple of pi. That is also wrong, because yes, this is an integer multiple of pi, but whereas if you see 3 by 4 into pi, which is not an integer, 3 by 4 is not an integer. The correct statement is it must be rational number multiple of pi. It must be rational number multiple of pi. That's a one way to say. Or simply we can say 2 pi by omega naught. 2 pi by omega naught must be rational number. What do you mean by rational number? Integer by integer form. So whenever you can write a number in terms of integer by integer, then we can call that as a rational number. So if this value is equal to rational number, then if I multiply with m, then if I multiply with m, then finally this total thing will become integer. Then this total thing will become integer. So first take down this, then we will write those points. Okay, take it. Observations. The first observation, continuous time sinusoids and phasors phasors are always periodic. Always periodic. That is unconditionally periodic. That is unconditionally periodic. Unconditionally periodic. And period is given by 2 pi by omega naught. And period is given by 2 pi by omega naught. Next, what about the discrete time case? There may be, may not be. Discrete time sinusoids and phasors are conditionally periodic. Conditionally periodic. And what is the condition here? And the condition is 2 pi by omega naught must be a rational number. Must be rational number. And period n is given by 2 pi by omega naught into m. 2 pi by omega naught into m. Okay, take it. Always periodic. I hope it's over. Take the question in your workbook, question number 12. Question number 12. X of t is equal to 4 plus 2 sine 5 pi by 6 plus 30 degrees plus 4 cos 6 pi by 5 t plus 60 degrees plus 3 sine pi by 7 t. Okay. Find the time period t. Find the time period t, capital T. That's what we have to find. Okay. Listen. First of all, I want to mention one thing here. DC signal. DC signal. Now let's say x of t is equal to, let's say 1. How it look like? This is 1. Now observe carefully. If I ask the question, is it a periodic signal or aperiodic signal? Is it periodic or non-periodic? How can we say this? Some people will say yes, it is a periodic. Some people will say it is not periodic. but actual answer is it is periodic signal. Yes, definitely it is a periodic signal. But that's not the matter here. How much is the period? If you are too much intelligent, you can say the value is equal to infinity. Period is equal to infinity. That's not correct. What you have done is, suppose DC signal means frequency is equal to 0 and the period is equal to 1 by f. So that's what you have used, so that you get the wrong answer. So that's not actually the period. What we can say, suppose if I say 0 to 1 second, if I take this part and keep on repeating it towards right and left, can I get the signal 1? Yes, I can get it. Suppose instead of taking 1, suppose if I take 2 seconds, if these 2 seconds, if I keep on repeating them, can I get the original signal? Yes, I can get it. So you can take any value of time. That means suppose let's say 0.5 seconds. If I take this value and keep on repeating them, I can get it. So I can say DC signal, no doubt a periodic signal. But only the thing is, you have to remember with undefined period. That means there is no such period. So you can say yes, this is exactly the period. You can take anything as a period. 0.5 seconds if you want to take as a period, it's okay. If you want to take 2 seconds as a period, yes, it is also okay. You can take anything as a period. There is no doubt it. Okay. So I can say DC signal is the exception we have. So it is periodic with a undefined period. That's what the meaning of it is. Periodic with undefined period. So anything can be taken as period here. There is no such thing, yes, this has to be the value. So there is no way you can take anything as a period for it. Okay. So first this one. Now let's say, coming to the question now. 4 is a DC signal, it is a periodic signal. So every sinusoid or cosine or phasor in continuous time case always periodic. So this signal periodic, this signal is periodic, this signal is periodic. So I can say individually everything is periodic. But what if I take the sum? Is it going to be the periodic? Answer is maybe, may not be. Understood or not what I am trying to say? See, individually this signal are periodic, no doubt. But the combination or the sum, is it periodic? So I can say maybe, may not be. Why, sir? Actually there is a procedure to say whether it is a periodic signal or not. So first let's say method 1. What is the method 1 is? Method 1. First take the periods of each signal, individual signals, T1, T2, T3 and so on. If you consider these values, then if you find the ratios of them, that is T1 divided by T2, comma, T1 divided by T3, comma, T1 divided by T4 and so on. Suppose any periods are there, how many periods are there? If you try to find out the ratios of these periods, if it becomes a rational number, that means this is a rational number, this is a rational number, this is a rational number, everything is a rational number, then we can decide the given signal is a periodic signal. So is rational numbers, then we can decide x of t is periodic. X of t is periodic. Okay, sir, it's nice. We came to know it is a periodic signal. Then what is the period of the signal? Then period of the signal is nothing but LCM of T1, T2, T3 and so on. So for these values we have to calculate the LCM. Okay, take it. This is the method 1. Usually we don't follow. We will have the next method, we can understand that. That is a very shortcut method. That is a direct method. We can say whether it is a periodic or not, what is the period of the signal. Okay, first take down this. Even this year also this kind of question was asked in the EC paper, 2009 EC paper. This kind of question was asked. See method 2. In the method 2, instead of taking periods, I can directly with the frequency. That means, let's say, we are having omega 1, omega 2, omega 3 and so on. That is nothing but the individual frequency. So I don't take the DC signal, it won't make any difference for me, but I will take the sinusoids. So it is having omega 1 frequency, omega 2 frequency, omega 3 frequency. Suppose there are other terms, omega 4, like that. Okay. Now we have to check the same thing, but only in terms of frequency. That means, suppose if omega 1 by omega 2, omega 1 divided by omega 3, omega 1 divided by omega 4, like that. If we try to find out these values, if they are rational numbers, again we can say the signal is periodic. And the period, how to calculate the period? First of all, we have to calculate fundamental frequency. Fundamental frequency. Okay. So if I try to find out the fundamental frequency, this is going to be GCF of omega 1, omega 2, and so on. So these values we have to find the GCF. Once we find the GCF, we get omega naught. Once we got the omega naught, we can find out the period, which is nothing but 2 pi by omega naught. This is the formula we have to go. Okay. First take down this, then by this method we can calculate what is the period for the given signal. Okay, take it. Make it fast. Okay. Let's see this method. In this method, how we can calculate that. First, omega 1. What is omega 1? 5 pi by 6. Omega 2, 6 pi by 5. Omega 3, pi by 7. Pi by 7. Okay. Now if I try to calculate omega 1 by omega 2, omega 1 by omega 2, that is 5 pi by 6 divided by 6 pi by 5. So it is nothing but 25 by 36. Is it a rational number? Yes, it is a rational number. Next, omega 1 by omega 3, 5 pi by 6 by pi by 7. So it is 35 by 6. So it is also rational number. So the ratios of frequencies is a rational number, then I can decide the signal is a periodic signal. X of t is periodic. Once it is a periodic, then what is the fundamental frequency? Fundamental frequency is nothing but GCF of omega 1, that is 5 pi by 6, comma 6 pi by 5, comma pi by 7. Now, what is the GCF of this? So many people will say pi, but that's not the correct. Remember, we know how to calculate the greatest common factor of numbers, but so many people don't know how to find out the GCF, that is greatest common factor of fractions. So remember, you might study this in the aptitude sessions. So how to calculate the LCM and GCF of, suppose let's say fractions are given. So for fractions, LCM is equal to, suppose LCM of fractions you would try to find out. This is nothing but LCM of numerators divided by GCF of denominators. GCF of denominators. Suppose if you try to find out GCF of fractions, then reverse. GCF of numerators. GCF of numerators divided by LCM of denominators. LCM of denominators. That's what we have to do. So in that way, suppose GCF of these fractions is nothing but GCF of numerator, that is 5 pi, 6 pi, pi, divided by LCM of 6, 5, 7. So which is nothing but pi by 210. This is what omega naught. From that we can calculate what is T. T is equal to 2 pi by omega naught, that is 2 pi by 210, which is 420 seconds is nothing but the period of the signal. Okay, take it. So here I want to make some observation. We already seen that continuous time sinusoids and continuous time phasors are always periodic, or we can say unconditionally periodic. Individually, sinusoids and phasors in the continuous time case always periodic, or we can say unconditionally periodic. But there is sum. If I do sum for them, will it become a periodic signal? Answer is maybe, may not be. This is the irony we have to think about. This is a paradox, we can say. So many people think that yes, individually they are periodic, then definitely the sum is also going to be periodic. No, it's not like that. So I can say the conclusion point here, individually sinusoids and phasors in a continuous time are periodic, but their sum is conditionally periodic. What is the condition here? The condition is the ratios of frequencies or the ratios of time periods has to be a rational number. The ratios of time period has to be rational numbers. That was the condition, it has to be satisfied. Clear? Okay. I am writing that point. Observation. Individually, that means only one sinusoid or only one cosinusoid, or we can say one what we can say phasor. If you take individually continuous time sinusoids and phasors are unconditionally periodic. Unconditionally periodic, but their sum is conditionally periodic. Conditionally periodic, and the condition is ratios of periods must be rational numbers. Must be rational numbers. So this is the observation what we made. Okay, take it.